Yeah, what's up, YouTube? All right, today's going to be freestyle. We've got a bunch of people doing quizzes, like to test their knowledge and see if they have questions. And if they have questions, they're going to ask them. The rest of them are going to just kind of ask questions up here. That's what we're doing. I don't know. So the request was to start with 17 basics. I can talk about 17 basics. Remember, this is not a test, which means a lot of these problems are going to be removed because normally I take stuff off to make the test and take more stuff off to make the final. But yeah, we can talk about 17. So check this out. This means whenever you plug in a number, you always get 3. This is saying whenever you plug in a number, you just add 4 to it. And then this one's a little bit more complex. So let's graph this by plugging in some points. What happens when I plug in 0? Well, I get 3 because that's what this does, right? If I plug in 1, I get 3. If I plug in 2, I get 3. Eventually, you're going to notice that it makes a little nice line. Oops, sorry. This kind of line. 1, 3, 2, 3, 3, 3, 4, 3, 5, 3. Not this guy. I was getting ahead of myself. That's how you graph that. If it was always equal 7, well, congratulations. 0, 7, 1, 7, 2, 7. Just go ahead and plot those, right? Here, we can do the same thing. Let's pick some points and see what happens. If I plug in 0, I'm not going to get 3 this time. I'm actually going to get 4. Because 0 plus 4 is 4. Hi.
So when it comes to negative 6i squared, do you just do it all? Do you square it all at the same time?
If you times it by itself, yeah, that's exactly what will happen, right? Yeah, yeah.
So it goes negative 6, and then it becomes 36, and then the I squared.
Negative 36 is your answer. Correct, yes. If we were to plug in another point like 1, well, we're going to get 5, right? 1 gets 5. 2 would then get 6 because 2 plus 4 is 6. And look, we get a nice little line that does this. So yeah, these first two are just lines. This next one is not a line, though, because it has a square. Yes, Kale? Ooh, I can help you. They're up here. People that are freestyling, make sure you're freestyling and not moving around, okay? So, no yapping to people that are trying to hear.
Hey, I'm not freestyling. I'm hearing too.
You do have 16? Yeah. Well, she said next to the 16, but you might have grabbed it earlier, I don't know. All right, so here's the first page. The last one, this is going to be a parabola because it's got a little square. And luckily, it's already in vertex form to help you find the bottom of your parabola. That's this guy right there. Right? So to find the vertex, we need to think what number for x makes this as small as possible. In other words, we need to make this 0. What do I plug in for x to make this equal 0? It's 2, dose, right? When you plug in 2, this is going to become 0. You'll square it. You'll get 0. And then you'll add 5. So 2, 5 is our vertex. And yeah, it will always kind of fit that pattern. 2, 5. 1, 2, 3, 4, 5. You talking about her hair? Yeah, it is tough. Yeah. Good for you. All right, so now we found a vertex. Okay, now we found the vertex. We need to find 3 points on either side of our parabola to make this little U shape. And here's how you do it. Okay, this is basically y equals x squared. All this extra junk is just to help you find where you're starting. So ignore all this extra junk. You already found where you're starting. And let's just focus on this. Y equals x squared. What we do, and it will be pretty much the same every time, you're going to plug in numbers for x and see what happens when you do this to it. This one's a pretty basic one, right? You're going to plug in 1 or negative 1. It's going to come out the same. Because when you square it, you're just going to get 1.
So you just find the vertex and you really do like for the 16 stuff?
Yeah, I mean, this is graphing a parabola, right? So notice that what this means is that if we go 1 or left to the right, because this is x, right? X is left and right. Then we go 1 up. So from our vertex, 1 to the right will get you 1 up, and 1 to the left will get you 1 up. So there's our first 2 dots on either side. If you go 2 to the right or 2 to the left, well, when you plug that in, you're going to get 4, right? Because 2 squared is 4. So that means 2 to the right from the first dot, the vertex, we'll go 4 up. 1, 2, 3, 4. And and 2 to the left will go 4 up because it's symmetrical. Kale, how are we feeling about this? Yeah? Okay. 3 to the right, or 3 to the left is going to get us our next 2 dots. And of course, what happens when I square 3? I get 9. So that means 3 to the right is going to go 9 up. Well, here is already 4. 5, 6, 7, 8, 9. And of course, it'll be symmetrical. There's your parabola. You graphed it. Yeah, super gross looking. So yeah, you need your vertex and you need 3 dots on either side. This finds your vertex, and then you do this thing. If there was a 2 in front of all this, you would have 2x squared here, and it would just double all these guys to 2, 8, and 18. Nope, this one's y equals x because f of x. All right, so that's the first page. Now remember on 17, there are going to be fewer questions than what's on here because this is a quiz, and normally I take questions off to make the test, and I take even more off to make the final, right? So if you're like, oh my God, 3 pages of basics, 4 pages of basics, well, there's not going to be that many on the test, right? Yeah. This is a normal quiz because we never took a test on 17. So I'm going to remove a lot of these questions, right? Yeah, there's not very much at all, right? What I've been saying. All right, cool. Let's find out if these are functions or not. What we need is called the vertical line test. Vertical line test. If it passes it, it's a function. So let's look at this graph. It's kind of gross looking because my pen bled through. I'm sorry. Vertical line test. We draw a vertical line. If you can draw a vertical line, perfectly vertical, and it hits the graph more than once, it's not a function. So I'm going to draw some lines. That only hits it once. That only hits it once. That only hits it once. This thing, there's no line I can draw, no vertical line I can draw that's going to hit it more than once. So this is a function. And usually if it's not a function, it's pretty obvious. Speaking of which, let's look at part B. Can you draw a vertical line that hits the graph more than once? Oh, you sure can. There's some you can draw all over, right? That breaks the vertical line test. So this is not a function. Not a function. Again, vertical line test tells you whether it's a function or not. Over here, it's kind of a weird looking function, but if you look, if you draw a vertical line, it really only hits each dot once, right? If I was drawing a horizontal line, that's a different story, but that is a different test. Vertical line test, it passes, so this is a function. Now look at part D. That's not a function. Because if I draw a vertical line right here, or right here, or right here, and there's plenty of others I could draw as well, it fails that test, right? So not a function. This is the most recent stuff we did in class. I don't know. I like doing easy stuff at the end of the year. I think it's good for you, good for your grade. Okay. I asked yesterday if I was going too fast or not. How's the speed today, guys? All right. Cool. All right. And everybody's different. It's hard to make a cake with everybody's favorite flavor, right? All right. Here's the deal. We want to find f of 2. So which function is f? The left or the right one? Which function is f? The left one. See? Hello. Bonjour. What's up? Welcome. Oh, okay. All right. Bye.
Is that Lululemon? Is that Lululemon bag? Yeah. Oh. Okay. All right.
Here we go. I got 17, 16, 15, 14.
Okay.
For you, reviewing page 270. Do you need a pen or anything? I'm gonna, is it okay if I give you a pencil? Bust this out for the last day of the year. Make it. This is true. That's something that I learned this year. I feel like I learned it in the past and I'd forgotten it. With multiple last names. Multiple last names. All right, so here's what we're doing. We want to find f of 2. So f is this guy, right? This guy's g. So looking at f, if x is 2, that's here, right? What do we get for y? We get 1. F of 2 is 1. Right? Because when you plug in 2 for x, you get this coordinate, which is 2 comma 1. How are we feeling? Good, good, good. All right, I'll use a different color for g. Let's use pink. So g of -1, that means we go over to the g graph, and we plug in -1 for x. So that's here, right? There's -1 for x. You're never going to believe this, but g of -1 is also 1, isn't it? Right? -1 comma 1 is what this is. So that's also 1. Now, this little part here is a little weird looking, but it's really not that bad. It says first you're going to find f of 2, and then whatever you get, you're going to plug it into g. Then whatever you get, you're going to plug it into f. So one thing at a time. F of 2, we can find that. In fact, we already did, didn't we? F of 2 is just 1, so this is 1. So now we need to do g of that, and then f of that. So now we just need to find g of 1. Okay, well, g of 1 is here. And guess what g of 1 is? It's also 1. Yeah, these graphs are kind of silly, but I'm too lazy to change them, so there you go. So g of 1 was just 1. So that means we just need to find f of 1, right? Because g of 1 was 1, right? So now we find f of 1. And this is kind of how all these end up being. You get f of 1, and it's this gross point right here. Can you estimate what that would be? A third, a half, something like that, right? As long as it's reasonable, I'm happy, right? So g of 1 was 1. So now we got to plug that into f. F of 1 is like a third or something. A turd. Pretty sure when I said a letter earlier, you guys said D's, so I feel like turd is okay. Oh, you said something else, though. I'm not going to say that. Yeah, I know. I'm not going to be saying that. All right. So, yeah, I know. All right, so that's the idea, right? We found f of 2, which was 1, and then we g'd 1. Well, that means we plug in 1 for g and also got 1. And then g of 1, since it was 1, we do f of 1, which was like a third, right? It's kind of like just a puzzle. A bunch of dolls inside each other, right? 1723. Guys, this is what we did on the first page, so just in case you weren't here. This is a parabola, and its vertex is what? Can anybody tell me what the vertex will be?
3, 4.
Yeah, 3 makes this 0, right? For x. 3 for x makes this 0, so I put the 3 in the x spot. And when we get this to be 0, we just get 0 plus 4. That'll be what y is, so yeah, it's 3, 4. And then it should grow just like this, because it has no number right here, right? It doesn't have a number in this spot right there. So it'll grow just like that. So what you do is you plot your vertex, right? Wherever it is, 3, 4. And then it's going to grow using this chart. I'm writing out with pictures what you should say. I'm pretty lenient on this. That's totally fine, right? And then what you would do is you would use this to fill out this chart, right? So 1 squared is 1, 2 squared is 4, 3 squared is 9, and then you would use these numbers to plot your dots. 1 gets 1, 2 gets 4, 3 gets 9. There's a lot of words there. I'm pretty generous on this one, guys. You would use this to find the vertex and this to plot your other dots. Something along the lines of that, okay? It's a good look. You remind me of a student I used to teach whose name is Alfredo. Alfredo Pacheco? Yeah. He rides horses now for a living. That's what he does. No way. No way. Really? Not right now, but I trust. Okay. Really? Okay. Rolling in the money, huh? All right. Esmeralda's is making bank, huh? Buying horses? Crazy. Good for you. All right, guys, do you remember when we did the vertical line test to see if they're functions? Now it wants to know if these guys have inverses. So we're not going to use the vertical line test. We're going to use the horizontal line test. And you're never going to believe how you do the horizontal line test.
Wait, let me see.
Kale, spoilers. He's right. We're going to draw a horizontal line. If you can draw a horizontal line, a perfectly horizontal line that hits the graph more than once, it is not an inverse. So check this out. Do you see how I drew this horizontal line and it hit it 3 times? That does not pass, so it is not a function. You are, or not an inverse. You are not the father. Not an inverse. Not an inverse. What about part B? Is there a horizontal line we can draw that's going to hit more than one dot? No. So it passes the test, right? There's no horizontal line you can draw that hits more than one dot. So this is an inverse. Okay. Or it does have an inverse is what we should say, but you get the idea. What about part C? Does it pass the horizontal line test? No. Definitely not. There's lots of horizontal lines you could draw that's going to hit the graph more than once, right? So this does not have an inverse. Now, this one down here trips up everybody because they think, wait a minute, I've got a line that I can draw that hits both of those things, right? But we've got a closed circle here and an open circle there. So open circles don't count, right? Open circle means we're not including that point. It goes all the way to that point, but doesn't include it. So that's totally fine. This does have an inverse. Well, that was page 4. That's all the basics on 17. And again, if you can get all the basics done in the final, you're going to be sitting pretty well off. Don't forget, just in case you showed up later, because it wasn't just you, I have recorded all of the basics and the intermediates for every single quiz, right? And I did that yesterday, so it is online. You just got to go in Google Classroom. In fact, I even have the notes that I made with those kids posted as well, so you can just click it and you can read them. There you go. Everybody cool with this page? Andy, we missed you yesterday. No, you don't need to be sorry. You were a person that is worthy of being missed. Billy took care of you, obviously, so we, you know, everything was all right, but. All right, what do you want to do now? Do we want to do more basics? Are our people over here chilling? Everything's working out just how you thought? You could, is everything working out the way you thought? Okay. Well, you can check the answers with the stuff I posted, right? So if you want to use this as a study guide to practice and check your answers, you can. Right? Just like normal homework, answer key is posted. I know, which is why we're here. All right, so, sure. While everybody else thinks about what they want to do next. Down to the bottom. Find all solutions to this. Cool. So you complete the square for -16, -17. And that means plus or minus root of 17 minus 4. Yeah, nailed it. Yeah, well, I mean, if you plug it, if this is right, if you plug this in right here, you add 4, gone. You square it, you get 17. What is 17 minus 17? 0. Mm-hmm. Oh, Dan the man's sending me some stuff. I'll have to check that out. Andy, we're going to be here probably until 9 o'clock tonight. So if you want to just leave that for the next day, it's fine. We're just taking finals. Thank you, Andy. But yeah, no rush. Seriously. There's going to be kids maybe even bringing food later on. So hate to ruin your work. All right. Well, thank you for being understanding. What should we do, rest of yous? What should we do next? What can I do for you?
Can we hit up maybe a little medium on 5?
Medium on 5? We can totally do that, yes, if that's what you want.
Can you do a little run through on 12.3.5, please?
12.3.5, yeah.
Just because I haven't dabbled with that type of stuff.
I understand. Yeah, this is definitely one we should talk about. So, these are really easy if you know what you're doing, because all we're going to do is we're going to multiply by a number that doesn't change anything. What's the only number you can multiply by that doesn't change anything? 1. So we're going to use a weird version of 1, and this is going to be based on this guy down here. We're going to multiply by the conjugate. What is the conjugate? What does it mean? Yeah, it's going to be the same thing, but the sign's different, right? So we're going to multiply by 2 plus 3i over 2 plus 3i, and what this is going to do is it's going to get the I out of the bottom. And that's kind of our whole goal here. So let's go ahead and start distributing. In the bottom, we're going to get 2 times 2, which is 4. And we're going to get 2 times 3i, which is 6i. Now, so far it looks like we haven't gotten rid of any of the i's in the bottom. But wait, there's more. Esteban's seen this episode. We're also going to distribute negative 3i to both of these, right? When we do so, we're going to get negative 3i times 2, which is negative 6i. Hey, look, it got rid of it, didn't it? That's the power of the conjugate. It'll get rid of your middle stuff, and your middle stuff will be i's. And lastly, we do negative 3i times 3i. Well, negative 3 times 3 is negative 9, right? What is I times I, though? I times I is I squared, which is negative 1, right? So when we do this, we're going to get negative 9 and negative 1. What's negative 9 times negative 1? Positive 9. See how it got rid of the I? So these go away, and the bottom is just 13. Now in the top, we're going to distribute as well. You're not going to get rid of your i's there. It's impossible to do that. It's started with i's. It's going to have i's somewhere. When we do 3 times 2, we get 6. 3 times 3i will be 9i. And when we distribute the 2i to everything in the top, we're going to get 4i. That's what they used to call me. And then 2i times 3i is negative 6. Do you guys see why 2i times 3i is negative 6? We get 6, and then I times I is negative 1, right? Thank you. That's why I'm here. So notice in the top, the 6's go away, and we get 13i over 13. And if you want to circle this, you totally can. But don't the 13s divide out?
Yeah.
They do. So go ahead and circle that. But if you want to, the 13s do divide out. You get I. Is that always going to happen? Absolutely not. My phone's blown up. Is it Dan the Man? It is Dan the Man.
You guys have a teacher group chat?
I'm sure they do, and I'm not a part of it. But no, Dan has my number. All right. This right here. We're going to multiply by the conjugate again. Crazy, right? Let's times by 7 plus I. And 7 plus I. So, that negative, just keep at the top. Don't worry about it. Okay, we'll deal with it later. What is 7 times 7? 49. 49. We're cooking. We're cooking. And you shouldn't be surprised that when we distribute the 7 here, we get 7i. And when we distribute the negative I, we're going to get minus 7i, right? That's why we multiply by the conjugate, so that middle goes away. Last but not least, we'll multiply that negative I times I. Everybody, what is I times I? But if we do negative I times I, it'll come out positive 1, won't it? Yeah. Mm-hmm. So the bottom just becomes 50. And now let's distribute the negative 3i into everything in the top. We're going to get negative 21i's. And we're going to get negative 3i squared. I'm going to write that down up here just so we can talk about it. Right? Negative 3i times I is negative 3i squared. Remind me, what is I squared? It's just negative 1, so this is just positive 3, right? That's it. We're just trying to get the i's out of the bottom. All right. Let's go back and work on some basics. Would anybody like to talk about some basics on a quiz? We did the 17s. We can do basics on others. It's totally fine. Nobody on God? I mean, they're all in theory, they're already on the video I posted yesterday. Same thing with all the intermediates, though, right? So, anything for you? Today's day 2, so it's pretty chill. Almost everybody's kind of doing their own thing right now, Kylie. So, since this is day 1 for you, it can kind of be your show. No way. Did you like and subscribe? It's okay. Don't answer that question. What can I do, guys?
I didn't even say yes or no.
Your head.
I was looking at you.
1321 on the intermediates. Oh, it's basic. Okay, 1321. So, guys, I'm on page 3 of the one with a 5 on the front. Sorry, it's 1321. So it's on page 3 of the one with a 5 on the front. Yeah. She's talking about the milds, right? I will do A and B. But for the people watching at home, I'll do both. So, we are completing the square. Yeah, we've been completing the square since chapter 13. That's kind of crazy, huh? This is the first time we actually saw it. Remember, to complete the square, what you're going to do is you're always going to take x and half of this guy. What is half of negative 6? Negative 3, not positive 3. Good job. Now, what this represents is x times x, which is x squared. It also represents negative 6x, right? But it's also going to represent negative 3 times negative 3. What is a negative 3 times negative 3? Do you see a plus 9 up here? Nah. So if we just leave it like this and put a plus 5, there's a plus 9 in here that isn't in the original problem, right? So because this is a plus 9 when you square it, we need to have a minus 9 on the outside to get rid of it. Otherwise, we've changed the problem. Because this one is saying complete the square. It says use factoring to check your answers. So this right here, if it's factorable. So, and this will help us with this one because this one is not factorable. So now what do? Well, we just simplify. And this is going to become negative 4 equals 0. And what we want to know is what is going to make this entire thing equal 0. This is a thing that we haven't done in a while, which is kind of tricky. So here's what you can do. Think. This thing, this giant thing right here, has to equal what number? 4. Only 4 minus 4 is 0, right? So you know this has to equal 4. Okay, cool. So you're squaring something and it's going to get 4. What do you square to get 4? Plus or minus 2, right? So what's underneath my finger, this thing right here has to be plus or minus 2. Either way, it'll come out to 4 when you square it. So we know that it's plus or minus 2. Okay, cool. But now we've got this minus 3 here that's going to screw everything up. If I just plugged in plus or minus 2 for x, it's going to subtract 3 and ruin our perfect 4 that we're going to get. So here's what you do. Just add 3 to it. Now, it's going to make more sense when we check our answer. So let's go ahead and check it right now. If I were to plug this in for x, this weird abomination, what's the first thing it says to do? What's the first thing it says to do? Subtract 3. So what happens when I subtract 3? I get plus or minus 2, right? Then it says square it. What happens when I square this? I get 4. And then I'm supposed to subtract 4. That gets me 0, right? So my first job was to figure out kind of what this thing had to be. And then I got to have something here that's going to take care of this, right? So I knew this had to be 4. What do you square to get 4? Plus or minus 2. But if I just plug that in right now, that minus 3 is going to screw everything up. So put the plus 3 there. You'll notice, like Aubrey was saying, that you're going to get 5 and 1 if you just do this, right? So this was factorable. But you can totally circle this. I don't care. This next one we're going to do the same way, but it's going to be a little bit more annoying. Multiply by 4, what are you talking about? Times this all by 4? Okay. All right, so same thing as before, but now we have to take half of 5. What is half of 5?
Half of 5 is 5 halves.
5 halves, right? 5 over 2. And you might say, well, 2.5 works for me, but that's fine. But remember, whatever you put here is going to be squared. I don't know what 2.5 squared is off the top of my head, but I do know what 5 halves squared is. It's 25 over 4, right? And we definitely don't want that, so we're going to have to subtract it. There is no 25 over 4 up here. And now, we have rewritten it without changing the problem.
Now multiply by 4 instead of making them multiply.
We can do that if you want. You can do it if you want. Because this is an equation, which doesn't happen very often, but because it's an equation, we're allowed to multiply by anything we want, right? So Briley's saying, what if we just times everything by 4? Put a 4 in front of here. Make that negative 25, because when you times by 4, the 4 goes away. Make this 8. If we simplify this all down, what you're going to end up with is negative, what, 17? So now we got to solve. And this one is much more complex, I will admit. So think about it. This entire thing underneath my thumb, what does it have to equal? It has to equal 17. Let me get out a little sticky note. So we know if I were to cover this up, this entire thing has to be 17, because only 17 minus 17 is 0, right? Okay, cool. Well, then the question becomes, what do you times by 4 to get 17? 17 quarters, right? So this part right here, let's fold this up a little bit more. And I like this method because it makes you confident that, yeah, only 17 fourths times 4 is going to get a 17, right? You get 17 from this, and 17 minus 17 is 0. Now, here's the thing. If we just plugged in 17 fourths, we'd be in trouble because this thing's going to square it, right? So what do you square to get 17 fourths? This is where things get a little weird. What do you square to get 17 over 4? The root of 17 over 4, right? So check this out. We know that this should be the root of 17 over 4. Plus or minus. Doesn't matter if it's positive or negative, right? When you square it, it comes out positive. So check this out. If I square 17 over 4, I get 17 over 4, right? The root is, it comes out 17 over 4. Times by 4, I get 17. 17 minus 17 is 0. So far, so good. But here's the thing. We can't just plug this in for x, because see how it's going to screw it up by adding this? So what we really need is we need x to be this minus 5 halves. If I plug that in right there, do you see the first thing I do is add 5 halves? Gone. Next thing I do is square it. Gets rid of the root. Times it by 4 gets rid of the denominator. 17 minus 17 is 0. So here is our answer. X equals, and this is probably one of the hardest ones we do in this entire quiz, is this minus 5 halves.
So many different articulate parts.
But again, you can really check your answer with this method, right? When you plug it in, you add 5 halves, gone. You square it, the root's gone. You times it by 4, the denominator's gone. 17 minus 17 is 0. No, not in this one. Because we're subtracting 17, so this should be positive 17. If you put an I in there, it'll come out negative. Yeah, you might be looking at a different one. If this was plus 17, then yeah, you would need an I. But that's a spicier problem for a different time.
I was looking at negative 17 over 4. Yesterday, how did you get a different answer?
What I probably got was something that is equivalent to this. Did I get like 21 over 4? This is 10 quarters. But if I root it, it's going to be the root of 10 over 2. So I need this to be 16. Root of 21 over 4 minus 5 halves. Yeah, why did I get 21?
Because 21 over 4 was what 17 was.
Oh, probably because I got 8 here, right? And that got me 17 quarters. And I probably wrote 21 instead of 17.
No, you did where you divided everything by 4.
Are you talking about
So then it was
Let me see.
20, negative
Did I get
25
common denominators? Is that what you're talking about?
Yeah, plus 4 over 4. I think you had this.
There you go. No, and you should be, because 4 over 4 is not equal to 2. All right. Go ahead and type that up in the comments, Briley, so people know. All right. What should we do next? Right, we got plenty of time. What should we do next? Any basics we want to go over on any other quiz? Reminder, again, for those of you that showed up late, this is an actual quiz. It's going to have much fewer questions from this chapter on the final than it would on a test, right? Because tests are already whittled down a little bit. Same thing with 17. It's a quiz, so there are going to be fewer 17 questions than there are. I think 5 is a tale of two cities. It has the easiest questions on it and some of the hardest, honestly. The other ones aren't too bad. What can I do for you? We can go over any ones you want. 14, 15, 16. Or these guys.
Nacho.
Yeah. Should I just start from the beginning? Let's do it. All right, here's how you graph this. You need to get it to look like what we did on the first page of 17, this thing, right? We need to complete the square. It's what we were just doing, but actually easier. So what we're going to do is we're going to do this, and we always need x and half of this guy. What's half of 10? 5. So this thing right here represents x squared, 10x, but it also represents 5 times 5. What is 5 times 5? I don't see any 25s here. So if you just leave it like this and put a plus 9, you've changed the problem, right? So we need to consider that 25 inside of here and get rid of it. That way we're not changing the problem. So now this is the exact same thing as this. It's just a different way of looking at it. And this is going to help us graph it, this way of looking at it. Everybody cool with 25 inside of here? Got to get rid of it? So let's simplify that down. We've got negative 25 plus 9. That's going to be negative 18. No, it's not. I was thinking 7 again from earlier, right? Negative 16. Yeah, please help me out. I didn't go to bed till 4. And I woke up at 6:30. All right, so let's find our vertex. Our vertex is whatever's going to make this as small as possible, because that's going to be the bottom of our parabola, right? Super important point to find. What value of x is going to make this equal 0 here? Negative 5. Negative 5 for x. So I'll put the negative 5 in the x spot. And when you plug that in, this whole thing becomes 0 minus 16. What is 0 minus 16? Negative 16. So guess where our vertex is? Negative 5 for x and negative 16 for y. Go ahead and plot that dot. Plot that dot. Down at the bottom. What's up? It is, because this is a 16, 16, 16 grid. So all the way down here is negative 16. That's helpful to know. Saves you from counting. So from there, we just need to find 3 more points on either side. Now, look at this. All of this junk is to help you find where you start. We already know where we start. It's down here, right? So we can ignore all of this except for this. This is how it grows. So let's make a little chart using that. Y equals x squared. Let's make our little chart. A lot of you guys have this chart memorized because you do it so often, but just in case you're new to the show, here's the idea. We're going to pick numbers for x. You can pick any numbers you want, but I'm going to pick really easy ones like plus or minus 1, plus or minus 2, and plus or minus 3. And what this is going to get us is 3 points on either side of our dot, which is what we need to graph this little U shape, this parabola. So I always pick the same numbers, and then I plug it into whatever this is, and I see what happens to y. So in this case, it's really basic, right? When you plug in 1 or negative 1, you're supposed to square it. What happens when you square them? When you plug 1 in and square it, what do you get? You get 1. And what this is going to tell us is that from our vertex, always from the vertex, we're going to go 1 to the right or left, because that's what x means, right or left. And we're going to go 1 up, because y's deal with up and down, right? So 1 to the right gets you 1 up, and 1 to the left gets you 1 up. Now we're going to do the same thing with 2. What happens when you square 2? You get 4. So that means from the vertex, not from these pink dots, but from the vertex, we're going to go 2 to the right and 2 to the left, and it's going to get us 4 up. So 2 to the right gets us 4 up. 1, 2, 3, 4. And 2 to the left gets us 4 up. And it will be symmetrical. Mars, is that going into the grade it now bin or hold on to it bin?
Grade it.
Grade it now? Okay,
Yeah.
nice job, kid.
Bye.
Bye-bye. Yep. All right. Last but not least, to find our next pair of dots, our last pair of dots, let's plug in 3 or negative 3. What happens when you square those? You get 9. So that means 3 to the right from our vertex goes 9 up. Well, here's already 4. 5, 6, 7, 8, 9. And of course, it'll be symmetrical. Once you have those dots, you may draw your parabola. It's going to do something like this, it looks like. But I'm going to be looking for those dots, right? Those dots are very important to have accurate. Okay. Next it is. You can leave whenever you want. It's up to you. It's all right. Yeah. Everybody's here of their own free will. Yes. Here's 1. If you times 1 by I, you get I, right? That makes sense. Cool. What happens if you times I by I? You do, right? Because I times I is I squared, and that's -1. What happens if you times -1 by I? You get -I, which is exactly what that is. I don't know if you could tell that was a minus sign there. But yeah, there was a minus sign here. But that's the same thing as I cubed. Do you see how we've done I 3 times? I cubed is -1, or -I. Right?
How do I apply that to a number though? Like, does it just look?
So if I have like I to the 99, is that what you're asking about?
No.
What are you asking about? Okay, what are you asking about?
Like, if I have -27, but there was an I that was being cubed, does it become positive 27i?
Yes.
Okay.
Yeah, no problem. All right, this one is one of the tougher ones on this. In fact, it's probably the toughest basic out of all the 14s, because before we can complete the square, do you see how we have this annoying -2 in front of here? Yeah. We're going to have to divide that out first. We're going to divide it out from everything. Then we're going to complete the square just like normal, and then we're going to push it back, and everybody forgets the push it back part. So here we go. Let's divide everything by -2, so that way we don't have a -2 in front of our x squared anymore. If you divide all of this by -2, you're going to get x squared. You're going to get -8x, because 16 divided by -2 is -8. And you're going to get positive 12, because -24 divided by -2 is positive 12. So just for a second, forget this is over here, and let's complete the square. So we're leaving that alone. We always need x and half of this number. What is half of -8? Not 4. -4. Make sure you're careful. A lot of people write +4 and they end up getting it wrong because it screws up all their numbers. So this is going to get us x squared. It's going to get us -8x's. That's what we wanted. But it's also going to get us -4 times -4. What is that? Do you see a 16 up here? No. So that would change the problem. So let's put a -16 to get rid of that. And of course, don't forget the +12 that was already there. So far, not terrible, right? Go ahead and times everything by -2 now. That way we get y on its own again. It's very important to have y on its own. So when we do that, we get -2 times this thing. Do not distribute it into here. You're squaring. You can't do that. Then we're going to do -2 times 16. That is positive 32. And -2 times 12, well, that's -24. If we simplify, we end up with +8 on the end. At this point, you should be able to tell the vertex, though. What number do we plug in for x to make this equal 0? You'll plug in 4. When we do so, this entire thing becomes 0 plus 8. What is 0 plus 8?
8.
So we found our vertex. Hooray. 4, 8. 4, 8. 1, 2, 3, 4. 1, 2, 3, 4, 5, 8. All right, now we found our vertex. We go back to the original, and we look at how it's going to grow. Remember, all this junk here is to find the vertex. This is how it's going to grow. Notice we have a -2 in front of that x squared now, right? So when we make our chart, we're going to base it off of that. We're going to square everything and then times it by -2. So this is our little growth chart. You know, like in the movies where they have like the thing on the wall where they measure all the kids as they grow, and then one of them dies and the mom's dead too, and then they're like all sad when they look at it.
No,
Up.
those movies are tough.
Ooh, yeah. You would. You would. You love that movie, don't you? Yeah. That's so on brand. That's so sad. So sad. All right, so guys, we're going to pick the same numbers we did before, right? But this time, when we square them, we're not just going to square them and be done. We're going to square them and then times by -2. So what is 1 squared? 1, no matter whether it's positive or negative, it's going to come out 1. But what is 1 times -2? -2. So what this means is from our vertex, we're going to go 1 to the right or 1 to the left, because that's what x means, right? And we're going to go 2 down, because y is either up or down, and this is negative, right? So we're going to go 1 to the right and 2 down. or one to the left and 2 down. This parabola opens downward. Then congratulations, you're done graphing because it don't fit. Yeah, you can just skip it. So it's like, oh no, bad news, it doesn't fit, but wait, good news, I'm done. So, all right, what happens when you square 2? Well, you get 4, right? But then we're going to times it by -2 and get -8. So these are our same numbers from before, we're just timesing by -2, right? So that means from the vertex, not the pink dots, but from the vertex, we're going to go 2 to the right and 8 down. 2, 4, 6, 8. Ooh, that's right on the x-axis. That's convenient. Easy to graph. And of course, 2 to the left will also go 8 down. Now, in theory, you should have 3 dots on either side of your vertex if they fit. Let's find out if they do. 3 squared is 9. But as Briley said, we're not going to get 9 because we're going to times it by -2 and get -18. So we got to go 18 dots down. Now, good news, it will actually fit. Right? Isn't this entire area 16 between here and here? And we're starting plenty up higher, so yeah, it will fit. So just go ahead and go down 18. So 3 to the right sends you 18 down. Yeah, you got to go from the vertex. So this was 8 down. So then we go 10 more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 for a total of 16 down. So it should fit. Looks like this. I definitely missed one of the dots. That's okay. I know my 8th graders have told me that Mr. Messer, if you don't make a perfect line, he marks it wrong. Good for him. But I'm just not that girl, you know what I mean? It's not my truth. So that was one of the hardest ones on 14. I'll be real with you. But it's not that bad with a little bit of practice. All right, let's turn the page. This one's one of the easier ones because it's a circle. You need to find the center, and you got to find the radius. Once you have that, you just plot your dots and draw. So to find the center, we're going to do the same thing we did before, but we're going to do it twice because we got x squared and y squared. First thing I like to do is rewrite this with all my x's next to each other, which is a terrible idea in real life, but a great idea in math. Bye, Kylie. So let's go ahead and complete the square. Kale, you know we need x and half of this. What is half of -8? This is true. It's not. Thanks, Kale. It's all right. And then, of course, this is going to get us x squared and -8x, but it's also going to get us -4 times -4. Kale, this one's really for you. What is -4 times -4? Try again. We're not adding, we're timesing. -4 times -4. 16. Do you see a 16 up here, Kale? I don't see a plus 16, so we better get rid of that plus 16 that's inside of here. Otherwise, we've changed the problem. All right, circles are really fun because you get to complete the square twice. We're going to need y, because this is a y, right? And half of 12. Reese, what is half of 12? Half of 12 is positive 6. Esteban, you get confused again. Your name isn't Reese. Is Dan the man calling me now? I don't think so. Hopefully it's not an emergency. Oh, okay, gotcha. I was like, which Nora? Okay. So yeah, this is going to get us y squared and 12y, but it's also going to get us 6 times 6, which is 36. You see a 36 up here? No. I don't see one either, Reese. White people get green cards too. In fact, most people, I think, that are white, or most people that have a green card are white. Green cards are for immigrants. Immigrants can be white. This is true. All right. All right, so here's what we're going to do. Everything that's not in these binomials is going to get moved over. So I'm going to add 36 over, and I'm going to add 16 over. That means we got this. Fun fact. If you add 69, nice, and 36, you're going to get 105. And if you add 105 to 16, you're going to get 121, which is convenient. Because technically this is distance formula without the root. So if you were to root it, what is the root of 121? That means our radius is 11, right? The distance from our center is 11. So I rooted 121, and I got 11. That's the distance from our center. And what is the distance from the center? Well, that's the radius, right? Yeah. Yeah, but you're right. 11. You're right. No fighting. No fighting. That is a dirty stereotype, and I will not stand for it. All right. Our center is whatever makes this equal 0. Well, what makes this equal 0? 4 for x. And what makes this equal 0? -6 for y. So there's your center. 4, -6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 4, -6. And we already know our radius is 11, right? So just go 11 in every direction and draw your circle. That's it. 11 in this direction. This is already at 4, so if I go 11 in this direction, I'm going to end up at 15, so that's there. This is already down 6, so if I go 11, it's going to end up slightly off the page, sorry. And if you go 11 in this direction, that means you really got to go 4 and 7, right? 1, 2, 3, 4, 5. And then you draw your circle, which is not actually a little circle in this case. It's kind of a big circle. That's okay. We're body positive in here. If you have a big circle, I support you. That's it. That was all the basics on 14. I'm assuming we're talking about math right now. The big circle is natural. Yeah. If you've got big circles or small circles, I support you. I respect that. All right, that was the 14 basics. What else would you like to do? We can do intermediates, we can do basics, we can do advanced, whatever you want. I don't care. 1341. So guys, remember that 12 and 13 are the one that has the 5 on it? I'm sorry. It's what happens when you try to make a cake with everybody's favorite flavor. You get something nobody likes. 1341. Ooh. Okay, this one is basic, but it's not easy. I'm not telling you because I don't know. I don't remember. One root of this mystery quadratic. Again, this one is basic, but it's not easy. One root of this mystery quadratic is 5 minus root 6. So a root is what makes it equal 0. It's one of the answers. Remember quadratic formula? It gives you your answers, right? So if this came out of quadratic formula, what would the other answer be? Well, we already got the minus, so that must be the other answer, right? Yep, that's going to help us solve the problem. So we know if this is one of the answers, the other answer has to look like this. That's just math, guys. Sorry. If one of them is something minus root 6, the other one's got to be something plus the root 6. No. Conjugate is always this. So here's what it's saying. We want to know what B and C are. Fun fact. The sum of your roots will always equal negative B over A. In this case, A is 1, so I'm not even going to write that. I'm just going to write negative B. So Briley, the sum of our roots should equal negative B. So here are our roots. What's the sum of our roots? If we add them together, what do we get? Sum. I'm sorry. No, you're not. 5 and 5 is, it's 10. So that means B got to be what? Negative 10, right? All right, I will pause. So here's the idea. This is not an easy question, even though it's a basic, okay? It's the first thing you got to know, but it's the first thing you got to know about something difficult. So here's what we know. We know that the sum of our answers, when you add them up, will always equal negative B. That's just a rule we proved earlier. Okay, pause. It says A is 1. 1 in front of the x squared. So if we add these up, hey, can you guys zip it? If you add these up, you're always going to get negative b. So when I added these up, 5 plus 5 is 10. What's negative root 6 plus root 6? 0, right? So this whole thing adds to 10. So if negative b is 10, right, these guys added up, then regular b is negative 10, right? That's logic. Again, it's not the most intuitive thing. The other thing you got to know to be able to find c is that the product of your roots will always be c over a. Now, notice that a is 1, right? We have a 1 in front of the x squared, so it's just going to be c. Let's find the product. What happens when you multiply these together? Well, we're going to get 5 times 5, which is 25. Okay. We're going to get 5 times root 6. But since they're conjugates, isn't the middle going to go away? 5 times negative root 6 will go away. And then what's negative root 6 times root 6? Negative 6, right? The roots go away, you get negative 6. What is 25 minus 6? 19. So guess what c is? It's 19. That's 19. So b is always going to be what you add up, negated. And c is always going to be these guys multiplied. There's a harder problem that has you prove that this is always the case, and once you see that, it'll make a lot more sense. But to just get this done, you just need to know that the sum always adds to negative b, so change the sign. And the product, when you times them, is always going to get you c. Yeah. Okay, section 4 of chapter 13 was kind of a tough section, so the first question is a hard question. But it's the first question, so it's basic, right? Basic does not mean easy. All right, what else can I do for you guys? I can, yes. So 13.1.2, for those of you playing along at home, the one Aubrey's asking for is on page 6. She wants the other 13.1.2. She wants this version. Yeah, I know. So if you want to zone out for this one, if you're not interested in the intermediates, that's totally fine. Here's the idea. It's on page 6 of 5, yeah. Well, one way to solve this and make yourself not have to think so hard is just to write out what this means. X plus a quantity squared means x squared plus 2ax plus a squared, right? When you distribute all that, you get this. And so now let's put on our detective hats. This guy, when you square it, expands to this, right? X times x is x squared. You get 2ax's, and then a times a is a squared. If this part is how many x's we have, right? And here we have negative a quarter x's. What times 2 gets you negative a quarter? What do you double to get negative a quarter? A negative an eighth, yes. If you double that, you get negative a quarter, right? Negative 2/8. So a's got to be negative 1 over 8. It's got to be. That way when you double it, you get negative a quarter, or negative 2/8. Okay, well, notice that a squared and c are going to be the same thing because they have no x's. It is 1 over 64, girl, because a squared is 1 over 64. Yeah, I know. This right here is the exact same thing as this, because isn't 1 times this getting you negative x? Yep. Fun fact. Fun fact. I'll draw a little like thing around it because it's a fun fact. Look how fun it is. A 14th, because you'll get 2 14ths, which is a 7th. You're asking the right question. Should I do the next one as well or no? No. Okay. Fun fact, those questions are there to get you thinking about something we did later on. So they're like really tough to think about, but when we actually solve problems that use this knowledge, it feels way easier. I don't know. Sometimes it's like that. Sometimes the journey there is tougher than the destination. I don't know. I'm running out of thoughts, guys. Oh boy. What can I do now? if you need half of something, that means dividing it by 2, right? So if I have 3/5 and I want half of it, I can just take 3/10, can I? Right? Because dividing by 5 and dividing by 2 is the same thing as dividing by 10.
So the next one would be a
14,
14.
it's got to be. Yep. If you want half, yeah, you can always do that.
So 14 squared is 196.
196, because 13 squared is 169 and 14 is just reverse. Yeah, it's 196 is right. Or 14 times 10 plus 40 plus 16. Yeah. Yeah. It's okay. My Algebra 1 kids can do 14 times 14 in their heads.
That made us do our squares all the way up to 20.
Nice. That's really easy if you know what you're doing, actually.
I remember some of them.
What's 21 times 21? Esteban's thinking, but he's not right. But you are thinking. No. Esteban's trying to think about, like, okay, it's going to be 20 times 20, but a little bit more, right?
20 plus 1 times
Oh,
Thank you.
441.
Here we go.
441.
Now we're cooking. So 400 plus 20 twice, that's 40, plus 1.
I've actually been doing this method a lot more recently. Yeah.
I'm never wrong, I'm just early, right? This is superior. Never wrong, just early. Memorizing up to 20 is a cinch if you don't have to memorize it. I don't have it memorized, I'll be honest with you, I just think about it. All right, yeah, I don't use my squares often enough to have them memorized. I'm a math teacher. All right, what can I do now? What can I do now? 15 basics? Please, can we? 15 basics are what's kicking everybody's butt. Ooh, it's only 3 of them? Oh my God, you guys are so, this is,
So maybe it's gonna be even less on the final.
it can't be more. It could be 3 or less. Does that make sense?
Yeah, but it should be 1.
The point of the exam is not to take stuff off to make it easier. The point of the exam is like, can I get this information from you with 1 question, or do I need 2, right? If I can get away with 1 question, I only ask 1. Does that make sense? All right. So like, for instance, see how I made the test? Do you guys remember the quiz? The quiz had 3 of these on it, right? I only needed 1 of them to get the point across. The reason there's 3 of them on the quiz is because it's the homework, right? But for the test, to get the answer for a problem like this, I only need to ask it once, right? So that's why there's only 1 of them on the test.
How much would my grade go up by if I get a lot?
So it depends, because remember how I'm not, this is why it's so dumb. I'm not allowed to touch quarter 3, which is really stupid, really dumb. If you know stuff, you should get credit for it. That's just my opinion. I don't know. That's just my opinion. If they know it, they should get credit for it. So I can't touch quarter 3. So what I do is if you get something that was on quarter 3, like from chapter 12 or something, right? If you get it right and it would have boosted your grade from a 4 to a 7, let's say, I run a spreadsheet. That's my real grading sheet, not Skyward. And whatever the grade came out there, I try to boost your final in order to give you the grade you would have got if I was allowed to touch it. So sometimes, like, we have some kids that do really badly on quarter 3 in Algebra 1, right? But then they locked in quarter 4, and now they know they're crap. They got over 100% on their final, even though they only did the basics, because that's what it took to give them the grade that they deserved. So, does that answer your question? Exactly. I can't tell you, because Skyward will not let me do this because they've locked me out of quarter 3. But you will get the grade you deserve, I promise. You will. Most people get really good grades on the final if they know what they're talking about. I did some calculation, just like real quick math in my head, and I made predictions of where people will end up. Based on what I know you know, if you take the final seriously, here's where you should end up. So I'm predicting that you will end up with an A.
Oh my God! Yes.
You have to do it though. Like, you can't be like, Mr. Mac predicted the future, I can literally do anything now. No, you can still screw this up, but I'm predicting an A. You want to know? Bripples, I predicted that you would get a B. That is only based on what I know you know. That's based on what I know you know, right? If you know more that I don't know you know, you're going to prove it on the final and you can go up. I've got you circled on here that you could move up to an A as well.
No, I could not.
Because there's a possibility there are things that you know that I don't know you know.
Yeah, but no, there's not.
Okay, then you'll probably end up with a b.
Take the B.
Okay?
Yeah,
Yes. Z squared times I. If z isn't z squared I or zi squared?
That means that's real. No, that means it's imaginary.
If z is an imaginary number and you square it, you're going to get a real number, right? Does that make sense?
But it'd be
No. Pause. Follow me. If you square an imaginary number and z is an imaginary number, they said that, right? It complex, whatever, right? It'll come out real. But if you take a real number times it by I, what happens? You get an imaginary. Yep. But if it were cubed times I, well, then it would get, this would come out like to a negative imaginary number, right? And that'll come out real, right? Because you'll get negative 1, which is a real number. Okay, fair enough. All right, 15s. Kale asked nicely.
Wait, what's 16 squared? Wait, let me guess.
Okay. I'm going to show you another way to do it. Which means we get 16 times 4 times 4. Do you know 16 times 4? Sure you do. 40 and 24 is 64. So that's all you got to do. 64 times 4, I believe you. Not 216. It's not 216. I know where you got the 16 from, and you're absolutely right. How is it going to end in a 4? It's 4 times 4 is 16, right? It's got to end in a 6. 256. What is 60 times 4? 240. What is 4 times 4? 16. 256. Because a long time ago we made a choice to have you memorize your times tables instead of actually learn them, and we have been suffering ever since. I know. Carry the 1. How'd that go? I'm never wrong. I'm never wrong. I'm just early. Right? That is such a bad method. And I know it because I learned it, and my best friend was like cranking things out in class, right? Just like able to like pop these numbers, right? Okay, pause, okay? Right? He was able to calculate all these things in his head. I'm like, how did you do this? And he did it this way. He would do 60 times 4 and add 4 times 4. And that's doable in your head. 240 plus 16 is 256. Changed my life. I used to suck at calculation. I was so bad at it, even when I was beginning to be a math teacher, until I started doing math that way. But the problem is we don't teach you guys that way, and that's why you guys suck at lots of things, and it's not your fault. Hi. 10i squared, which is negative 10. All right, solving this inequality. So here's what we're going to do. We're going to factor this thing, which everybody's like, oh, God, I forgot how to do that. Oh, God, oh, God, oh, God. I'm going to help. This one's kind of a tough one to start factoring, but that's because technically we learned factoring last semester, and so I'm throwing you a curveball right off the bat. I apologize, but there you are. Okay, guys, we need to think of ways to multiply to this thing. I definitely need x and x to get x squared, right?
Yeah.
What's the only way to multiply to 2, though? 2 and 1, so we're going to have 2x times x gets us 2x squared. Are we cool with that?
Yeah.
That's kind of locked in. I like to start off with the things I know have to be true. Got to be 2 and 1. That's the only way you can make 2. Got to be x and x. The only way to make x squared. Do you see? Yeah, see, he's yep. So right here, whatever goes here is going to multiply, and it's not going to have an x in it, right? So what's the one thing without an x in it? Negative 21. So these guys are going to multiply to something without an x in it, and that something got to be negative 21. Now, Esteban's right. We do need a plus and a minus, and here's why. The only way to multiply to a negative, without imaginary numbers, is to use plus and minus, right? 2 negatives don't multiply to a negative. 2 positives don't multiply to a negative, so it's got to be plus minus. I'm going to guess the plus sign goes here, and the minus sign goes here. Do you know why? Because I need a positive 11 x's, right? Do you see how I'm going to get my x's from here? Right? I'm going to get this many x's, something times 2 x's, and it'll be negative, right? Oh, did I goof the signs? Oh, God, I'm having a stroke. Yeah, that's what I was trying to predict. I just wrote them in the wrong spot. So here's what I'm thinking. I want the plus sign here. Probably, you can be wrong, right? This is just educated guess at this point. I think I want the plus sign here so I get a big positive number when I double it, right? And I get a small negative number when I times these. Together, that should make a positive 11. So my numbers here and here are either going to be 1 and 21 or 7 and 3. Probably 7 and 3, because putting a 21 here is going to get me 42. That's way too big for 11. If I put a 7 here, what's 7 times 2? 14. And my other number would have to be a 3, right? Do you see I'm getting minus 3 from this? 14 minus 3 is positive 11. We've solved the puzzle. I'm going to be real with you. If this is your first time locking in on factoring, that is not the first one I would show you. That's why I did it last semester, and I did it a little bit in Algebra 1 as well. But it's okay. We're going to survive. Once we're here, can anybody tell me what number makes this equal 0? 7. -7. Thank you. If she had said 7 and had done all of this, I would have marked it correct on the final, because we're not about getting better. We're about getting a final grade on the final. So there you go. That's an example of a small mistake that I would have brushed aside. Clearly she knows what she's doing. She just missed the negative. Now here, if you told me 3, I would mark it wrong, because 3 does not make the 0. If you plug in 3, you get 6 minus 3. What we need is 3 over 2, and here's why. If you plug in 3 halves, what's the first thing it asks you to do after you plug in 3 halves? What's the first thing it asks you to do? Nope, first thing it says is double it, right? If you double this, you get 3, and 3 minus 3 is 0. I'll say it again. If you plug this in and double it, right, you get 3, and 3 minus 3 is 0. So this is the number you need. You need to be aware of that 2. It's going to double it, right? All right, now it says we're going to graph the solutions on the number line. So we're not done. We're not even done with this one. I know, 15 sucks. Everybody hates 15. So the one sacrifice I really made with your Algebra 1 classes, we didn't talk about inequalities, because it often gets cut in a lot of algebra classes, and you guys needed help with pre-algebra. So I had to cut something, and I cut that, which is why we're weak at this stuff. I'm sorry. All right, so we're going to graph these 2 points. Isn't 3 halves bigger than -7? So we should probably put 3 halves on the right and -7 on the left.
Yeah, I like that.
And here's what we're going to do. If we plug in 3 halves, we know this whole thing becomes 0, right? I'm starting to lose them. If I plug in 3 halves, I know this whole thing becomes 0. Do we want this to be equal to 0? No.
It has to be bigger.
Open circle, less than actually. -7 also makes this equal 0. Do we want it to be equal to 0? No. So open circle. We're not including those. What's important about these values is there are critical points. It means that's where things can go from positive to negative, and that's what we're looking for. We're looking for negative, right? So let's pick some numbers on the left of -7. Yeah, -9 is a good point to pick. So if I plug in -9, does this come out negative or positive? Negative, right? Because it comes out -2. If I plug in -9 here, I get -18 minus 3. That's definitely negative. What happens when 2 negatives multiply? Assuming we're real numbers, it'll come out positive. Do we want this to be positive? Nope, so we're not coloring it over there. Pick a number between -7 and 3 halves. Pick a number in between. 0. If I plug in 0, what does this come out? Try again. It comes out negative. If I plug in 0, it comes out? So a negative times a positive is a negative. Do we want it to be negative?
Yeah.
Color it in.
We live for this.
Yeah.
I've been blessed in that a little
Girl, get a grip. All right, pick a number bigger than 1.5.
200,069 billion.
200,069 billion doubled, minus 3 comes out positive, right? 200,069 billion plus 7 comes out positive, right? So both these come out positive. What's positive times positive? Positive. Do we want that? No. There you go. We have our graph. We did it. Yeah. All right. Congratulations. You have a really easy problem next that everybody goofs up.
I have a question,
What's your question?
but it's not related to that question.
What? I'm going to guess what you mean. If it's an equation, you don't have to factor things out. You can just divide everything out, right? Because you can divide to both sides. But if it's not an equation, you have to factor. Because you can't divide to both sides because there aren't both sides. There's no equal sign, right?
So I don't have to factor it out.
If it's an equation, you can just divide. As long as you're not dividing by 0.
Yeah. Okay, but what about the other time? Like when it isn't an equation?
Then you got to factor it out. You got to put in parentheses and put a 2 on the outside.
But when did, I remember having to divide by 2 or something. Why did I have to do that?
Half of a number to complete the square, right? You need half of the middle term.
But after I have it out at this point, do I just have to?
I'm pretty good at reading minds, but I'm not perfect. But I am pretty good at it.
At this point in this,
You got to distribute the 2 back to everything.
and then that's it.
Yeah.
Oh.
So you get you -8, -5, and that'll just have a 2 in front.
Okay.
Yep.
Well, I did this one wrong just for the other.
That's fine. That's fine. Yeah, Briley also likes to factor even if it's an equation. That's why you like the 4 in front. Instead of dividing by 4, you like put the 4 in front. Yeah. Yeah. Can do it if it's an equation. The reason I teach it the other way, Briley, is because people always forget when it's an equation you can divide and when it's not an equation you can't. If I teach division, they'll do it when they can, right? All right. So, graphing the sky. Congratulations. This is really easy, but a lot of people screwed up, so I don't know. Notice that this is going to be a quadratic because it's squared, right? We're going to get a parabola. This junk is to help you find your vertex. Notice it has no middle terms. This is really easy. What number do I plug in here to make this equal 0? The squared part. What do I plug in? Nope. You're thinking too hard. This is the square part. Think of it as like this, Esteban. If I had like this, what number would I plug in? I'd plug in 0, right? They didn't write the -0 because why would they? So to make the square part 0, you literally just plug in 0. Now, what am I plugging in 0 for? X or Y? So put the 0 for Y. And when you plug in 0, this entire term becomes 0 plus 4. So X will be 4. Are you guys smell what I'm stepping in? This is really easy if you don't screw it up. Just take it slowly. You clearly need to plug in 0. And then if you add 4, you get 4 for X. So 4, 0. 1, 2, 3, 4. 0. Right here is our vertex. Okay? Right here. Now let's make our little chart. Remember, we don't need to pay attention to anything except this when we're figuring out how it grows. So, here we go. Don't worry about less than right now. We'll talk about that later. Just make it an equal sign in your head. We'll deal with the less than later, okay? Now, in this case, are we going to be plugging numbers for X or Y? In this case, we're plugging in numbers for Y, right? That's the thing we're going to square and see what happens. So go ahead and plug in your favorite numbers, 1, 1, or 1 and -1, 2 and -2, 3 and -3. And let's do it. So, what is 1 or -1 squared? 1, but then it negates it and we get -1. 2 or -2 squared is 4, but then we negate it so we get -4. 3. When you square it, you're going to get 9, but then it says make it negative, so we get -9. From our vertex, we're going to plot these dots. Hi, Graz. Bye, Graz. Oh, maybe it's not Graz.
Is it Downey?
It might be Downey, yeah. All right, so here's what we're going to do. We're going to do what this says. Do you see how it says if we go up or down 1? We go left 1. This is super important. This is saying if I go up or down 1, right? Because it's a y value. I'm going to go left 1. Does that make sense? Up or down 1 gets you a left 1. So we're going to go up 1, left 1, down 1, left 1. This parabola opens to left. It do. It opens to left. That's what happens when you switch x and y. It's not going to go up and down. It's going to go right or left. In this case, it's left because negative, right? 2 up or 2 down, because they're y values, is going to send you 4 to the left because it's an x value. So 2 up, 4 to the left, 1, 2, 3, 4, right there on the y-axis. 2 down, 4 to the left, also right on the y-axis because it's symmetrical. Do not draw your parabola when we're done. Just leave your dots. I will explain in a second. This one means up 3 or down 3, we go left 9. So up 3, left 9. 1, 5. That's 9 because we were already at 4. And now, go back and look at this. Remember, what we've graphed is where it's equal to. Do we want where it's equal to? We want where it's less than. If it had a line underneath, it would want equal to, and we'd use a solid line for our parabola. But do you see how it doesn't care about equal to? If we don't care about where it's equal to, we do not care about what's on the parabola. Again, no equal to, so we're going to use a dashed line. If it had an equal to, we would use a solid line, just like we did in the previous problems. But we're not done. There's one last thing. It wants us to color in where it's less than. So here's how you do that. Let's pick a point that's not on the parabola. Let's do 0, 0. If 0, 0 works up here, then this is where less than is. If it doesn't, well, then this must be it, because that's the only other spot it could be, right? If you want to test another point out here just to prove it, you can, but like if it's not here, it's got to be there, right? So let's plug in 0, 0. If I plug in 0 for x, I get this, and if I plug in 0 for y, I get this. What is 0 squared?
0.
What happens when you negate 0?
0.
0 plus 4 is?
4.
Is this true?
Yes.
So guess what we're going to color in? The inside of the parabola. Sometimes you do color the outside. Pop quiz. If there was a line underneath this less than sign, if there was a line underneath it, how would that change the graph? If there was a line underneath the less than sign, how would it change our graph? If we had this, how would it change the graph? It'd still be less than, so that's this, right? This is where less than is. Where would equal to be? On the parabola, we would use a solid line if that were the case. Just like when we use an equal sign, normally we make a solid line, right? So watch out for that. Warning, foreshadowing. AMGM inequality. If you have notes about how to do this, it is literally the same every time. The bad news is, it's the final. Can you use your notes? No.
How do you remember this?
You don't. You don't. That's the key. Most things that you're going to learn when you get to college and stuff are not memorizable because it's too much. You have to be good at thinking. So here's what you're going to do. You're going to you think in concepts. Step 1, simplify. Step 2, run it backwards. You got that memorized? Here we go. Let's write this out. It is saying that we want to prove that this is always greater than or equal to this. Step 1, simplify. How can I simplify this?
Multiply by 2.
That's an option. I can also square everything, right? Let's go ahead and multiply that 2 over.
This is the way. Square it is.
How can we get rid of that root? Square it. If I square something, you do not distribute squares. Do you see how squaring that got you this?
Yeah.
For the love of God, do not distribute the square. You do not get x squared plus y squared. You get x squared plus 2xy plus y squared when you distribute. If you want to go ahead and distribute it, go ahead, but I'm saving some room. X times y, you get another x times y, 2x times y is y squared. Yeah, we should probably get this to be 0 on one side, right? So what if we subtract 4xy's?
Now you get to negative 2xy.
This is where a lot of people get goofed because they think I just made this negative. I'm not. I'm subtracting 4xy's from this. If I have 2 of them and I take away 4 of them, how many do I got left? Negative 2 of them, right? So again, what have we done so far? We're just like simplifying, right? Get rid of roots, get rid of fractions, right? Make everything 0 equals 0. Technically, it can be equal to 0. And now at this point, we want to condense this, right? Simplify, get fewer terms, right? Simplify. This is actually a perfect square. What do you times by itself to get this? Well, definitely x and y and a negative, right? Because otherwise you'll never get a negative in the middle. You get a positive either way. So guess what this means? Something squared has to be positive. And we know this is true, right? Whenever you square a real number, you'll get something positive. That's what this means. Or, well, actually, it means not negative because 0 is an option as well, right? All right, I'm going to pause right now. Because if you can simplify to here, all you got to do is run it backwards and you win. So I'm going to pause just for a little bit. Again, no memorization necessary. I just simplified stuff. The first person that proved this thing did the exact same thing. They're like, what if I simplify? Does something pop up? Oh my God, it does. I can use this to prove it. So here's the actual proof. The actual proof is just going to run this backwards, right? Because this assumed this was true, which you can't do, right? We're trying to prove that. So here's what we're going to do. You can't assume. That's right. So here's what we're going to do. We're going to start with what we know to be true. When you square something, it's never going to be negative, right? We call that the trivial inequality. I like writing TI because I'm lazy. Okay? So we're starting from this. The reason we stopped here earlier is because this is a fundamental truth. If you square something, it's never going to be negative. Now, how are we going to get from here to this? Well, we definitely got to talk about x and y, right? What are we going to replace a with? B ain't x and y. We want to make this have x and y in it. We want to replace it with x and y. But what specifically? X plus y, x divided by y, x minus is the way. Do you see how that's going to get us back? That's why we did this way, so we could figure out what we're going to replace a with. Let a equal x minus y. If that is true, you now have this. Right? A is just some number. X minus y is some number. Why not have them be the same number? From there, we run it back. How do we get from this back to this? From this back to this. Distribute, right? So that's the distributive property. So by distributive property. How do we, this is the one that trips everybody up. How do we get from here to here? Nope, we're going from here to here. We need to add 4xy, yeah. We need to add 4xy. When you do that, you're going to end up with this. That's by the additive property. Because you're allowed to add things to both sides. That's totally legal. Now, how do we get from here back to here?
You added the 4 up to the right.
We already added, yeah. We already added, right? So we already have that. Only thing that changes from here to here. Yeah, we need to factor, right? That's by factoring. And then how do we get from here back to here? We rooted everything, didn't we? Right? Or we squared it originally, but to go backwards, we're going to root. So if we root everything, we get x plus y greater than or equal to the root of 4xy. Well, that's just 2 root xy, because root of 4 is 2. By root. And then last but not least, how do we get from here back to the thing we want to prove? Well, you got to divide everything by 2, right? Divide by 2, divide by 2. So division property. I'm going to be honest, this is one of the hardest ones. But it's not bad if you think, all I got to do is simplify, and then I run it backwards. That's it. No memorization. I do not have this memorized. Good Lord. Why would I?
No, I'm here now.
Yeah.
One thing leads to another, and then you're...
Yeah. I'm going to simplify. I can zoom in again. You're welcome. That's true. You do. And 25 to rent a car. Where is Geese? I predict a B or a C for her. She could be here and do better. Maybe they're coming later. Maybe. I love Reese McKinney. Me too. But I love you all too much to leave. All right. I know. Good for you for having boundaries. I'm in an abusive relationship. All right, that's all the basics for 15. And 15 is probably the worst. Huh? Oh, I'm sorry, Kale. I'm so sorry. I'm so sorry. And I like putting little boxes at the end to prove I'm done. You don't have to do that. I don't know what we're doing next. Kale just wanted to finish this up. What can I do for you? Hold up, I can't hear. What's up?
Like what portion of it's gonna be like not basic? Like how many
That's a good question. I would estimate way more than half is going to be not basics. But here's the thing. You don't need to do way more than that. You can do just the basics and achieve a 70 in theory, right? Hello. Can I look at it?
I have no idea.
See, okay, so if we, no.
No.
It wants it to be a square binomial. This squared is going to get you 1 over a really big number, not 1 over 16. What do you square to get 1 over 16? A quarter. Yeah, it's a quarter. Which means this guy, which was B before, but it's C now. I hate how they changed that. When you expand all this out, you're going to get x squared plus 2 quarters x plus 1/16. So this is equal to 2 quarters, also known as a half. Yeah, it's sorry. I wish they used B again. I don't know why they use C. It's called disassociating. Look it up. Good for you. Girl, you're ready. Just go to bed. You'll be fine. Where is this drive to succeed for the other 364 days of the year? You do. You do. But you need to spread it out more. That way you can relax the day before. The day before a game should be a rest day, not this. No, all you're doing is giving into your anxiety, and you'll never satisfy that. Anxiety should drive you 364 days a year, and then on the 365th, the day of the game, right? The game day, anxiety should take a hike. Just send it. It's yours. Have it. It does not. Okay. When I clean up my desk, sometimes I find extra pens and I put them over there for people to borrow.
This is. Oh, is that the earring right there? Like it looks like it could be my earring.
But it's not. It's like some kind of trap. You put it on and it's not really an earring. It's like some kind of thing. Someone's trying to trap you. You too. I'm very proud of you. You're going to be fine. You're going to be fine. You are capable of anything. Do you know that?
Yeah, everybody's capable.
No, they're not. You really are. What you choose to do with that is up to you. And I support you in that decision. But I think the world of you. Do you know this? Good. Now go away. Bye. Right, later, Kale. Oh. Bye. And then there were 4. What are we doing, party people? Well, you're doing a great job of that. What? I've been wanting to leave. Yeah, I know. You guys been yapping at the storm. She doesn't have a restaurant named after her? Jeez. No way. She's the mayor. Mm-hmm. Well, we're still recording.
So do you think that I'm acquired enough knowledge to do at least like half?
It's hard to say, kid. There's
Wait, what do you have?
like if time understanding takes time, and what you have is very little time, and that makes things really risky.
What am I projecting for?
I'll answer that in a question in a second. Time makes things more stable, and we have very little time, and we just learned this stuff. So that means it's very hard to predict. Does that make sense?
Yeah.
You should do your best, and whatever happens, happens. Okay? Being here made a big difference, though. Really did. Being here is key. Not just here, like today after school, but like here. Being here. Yeah. Okay. Esteban, to answer your question. Running the numbers in my head, my prediction, and you are like all over the place, right? I think a B is very reasonable. I think it's a reasonable expectation. But here's the thing. You could end up anywhere between an A and a D.
A and a D.
A and a D. Depends on who shows up. If you show up and lock in, anything's possible. If you don't lock in, you can end up at a D, right? That's just how it is, right? But very few people have that power to have so much control over their grade, right? So just with great power comes great responsibility. I don't know.
Wait, if I get a D, do I pass on?
Yeah, D's passing.
No, me.
Yeah, yeah.
But, like,
Wait, on the final?
Like my grade list.
That's a good question. I don't know. I don't know what you need on the final to pass. But if you end up with a D in the end of the day, you'll be fine. And I think it's very possible for you. I really do. I really do. But you got to lock in.
There are a lot of intermediate.
Okay.
If you had locked in last week, we're talking about a C.
Like,
Easy.
At least a few weeks ago.
Right. If you did it a few weeks ago, we're talking about a B. Right. But last week, if you had locked in, you'd be sitting with a C. Casey locked in a little bit last week, and it's going to make all the difference for her.
Yeah.
Right. It's going to be close, but it's going to make all the difference, I think. So, yeah.
There are a lot of intermediate on the 13
What?
There are a lot of intermediate on the 12 and 13.
Tell me about it.
From a D to a B, I'm thinking an A,
I'm
buddy.
just gonna go and watch a video from yesterday.
I think that's good, but rest first, okay? Rest first. Make sure you guys sleep tonight. Sleep is super important. All right, Esteban, you're taking off? Hasta luego.
Wait, look at the reset.
There you go. Yeah, no problem.
Stay there.
Ooh, that's right. All right, bye-bye.
What's up? How we doing?
Butt cheek candle? Is that what she just said? Oh, man. And then there were two. So should I turn off the video because you're not going to ask any questions? You're just going to kind of sit there and do your own thing?
Yeah, and I'll also ask questions. It just, I don't think it'll be, it won't be beneficiary.
Okay, I'm turning it off now.
No, we can stand up.
No.